So you guys remember back when we did SOHCAHTOA and I did this crazy problem where I went to Arizona and helped my sister move and all that stuff?
Yes.
So I kind of lied to you, just a little bit. So I did it, but I didn't do it the way I told you I did, because math is the kind of thing, like if you take the SAT, there's a lot of questions on the SAT that if you have a certain amount of math knowledge, you can solve it, but it might be a hard problem. But the more math you know, a lot of times you find shortcuts to doing the same kind of problem, right? You now have a better way of doing this. What was the process we did before?
I remember it was proportion with sine.
Yeah, you had to set up two, they ended up being tangent proportions, right? And you had to set up like a system of equations, and it was kind of involved. Think of it now in terms of law of sines. Like, just take this weird looking triangle. Do you know more information about this little triangle? Mm-hmm. Like, do you know what this angle is? What's this angle right here? 165, how'd you get that? Okay, so now I know this angle, right? If I know two angles, do I know this little tiny angle up here? What's this little angle got to be up here? So those add up to 175, so this would just have to be 5, right? Think law of sines. Can I find this measurement? What's my law of sines? Where's my pair? My 100 now goes with the 5. So I can now just say the sine of 5 degrees is to 100 as the sine of 10 is to x. I can just start using the law of sines to solve this whole thing. And once I have this measurement, now I can use SOHCAHTOA, and I don't have to set up a system of equations. Like, there actually is an easier way to do this. Just by setting up a law of sines equation, solve for this. Once I have that, let's say I want this measurement. Now I can do adjacent hypotenuse. I can do cosine of 15 equals y over x, which I'll know by solving this, right? And I can do the same thing to find this measurement over here. You don't actually have to set up a system of equations all the time if you know more laws. Does that kind of make sense? So when we did this, we didn't have the law of sines in our toolbox. We didn't have that ability. Now that you have that ability, you can pull that law of sines out in a lot of different applications. So some of those problems we did earlier this year that were kind of hard and tricky, they get a little easier. And by the way, do you think the law of sines works for right triangles? Absolutely they do. Law of sines works for any triangle. Not just, non-right triangles. It actually works for all right triangles. So some people actually, like historically, when I give the exam and there's some SOHCAHTOA questions on there where you just got to solve a right triangle and then some non-right triangles, could you use law of sines all the time if you really wanted to? Yeah, you really can. It gets weird because if you have a right triangle and let's say I know this is 12 and this is 20, like let's say I know that and I want to find that side. Well, I mean, the easy way to do it would just be sine of 20 equals x over 12, right? What would my law of sines be? Sine of, where's my pair? 90 and the 12. So sine of 90 is to 12 as sine of 20 is to x, right? What's sine of 90? It's 1. So what you're really doing is just setting up a weird proportion with a 1 in there. But it will work. You're going to end up doing 12 times the sine of 20 anyway. It's just, it actually adds a step to it because SOHCAHTOA is easier. But, you know, sine of 90 is just 1, so it's not gonna fail. Cool?
I haven't seen one of these done since Friday, so you should just keep going through it.
Just keep going?
Go through it.
We got more to do. We got more. All right, anything else? Any actual questions for homework you want me to do? Now's your chance. Anything from the homework you want me to do? You want me to do more?
Just do one problem.
Pick one.
Number 3.
I did 3.
I don't remember. It's Friday. 30.
We should have a snow day today.
You know, it was a little snowy today.
Yeah, some guy almost ran me off the road on the way in.
Oh, that was me, sorry.
I missed.
White truck that would not get over, so he's like, no, I'm gonna make this car get over. Instead of this big truck. Right into a big bang. I'm surprised my car got out. I was screaming at him, flipping him off out the window.
Oh, I would have too. Hey, John, how did you drive a white truck?
I wanted him to turn around and very serious.
Are you sure it was white?
Yeah, it was wet.
That's white
And
truck.
not silver?
That was wet.
Huh?
Mr. Fink, I see your truck.
Things like that.
That's pretty nice.
Yeah? So where's my pair? Here's number 30. Where's my pair?
P.
42.
Wait, actually.
I know P and P, right? Okay, so sine of 42.9 is to 87.6 as sine of 31.7 is to little q d butterfly. Yes? Can we solve it? Okay. What mode do you gotta be in? Degree?
It doesn't matter.
Oh, it absolutely matters.
Oh, okay.
Anytime you're typing in like sine of an angle, cosine of an angle, absolutely it matters. So I would do 87.6 times the sine of 31.7. Get that answer. Divide that by the sine of 42.9. And there is my Q. So Q equals that. So how am I going to find the missing angle? 180 minus, right? So I'll just do 180 minus the 31.7 minus the 42.9, and you get 105.4. And then what's another proportion I could set up? I would just use the sine of 42.9 again, is to that 87. Use that every time. And now I can just do sine of the 105 is to little r. And again, when you're done, what are the two checks that you should always just quickly go through to double check to make sure things make sense? Biggest angle has to be opposite the biggest side. Smallest angles opposite smallest side. And the two small sides. So if this is 87 and this is 67, what does this side have to be? Like, what's the range of numbers that this side here has to be? We know it's got to be the biggest side, so it's got to be bigger than 87, right? It also has to be less than a certain number. Those two added together, right? So if you add those two together, it has to be smaller than that. Cool? Is it two difficult checks? No. Two easy ones.
Wait, but on the, so for a right triangle,
Yeah.
you just would do the, so on the calculator you do the first step. Because if you're just going to divide it by 1.
Yeah, you just don't need to divide by 1. It'll still work. It's just the 1 becomes irrelevant there. All right, give me your homework. Yeah. Yeah, it's on my desk. It's in my desk.
I already turned it in. It's in Ohio. Not really.
Okay.
Might be better.
Oh, that was yesterday. In Ohio. Yeah, but it was very
So, Friday, we talked the different cases that you could potentially run into, right? If we see angle, side angle, or, so, on test day, when you're given a problem, the first thing you're going to be given is 3 pieces of information, just like the problem we just did with this, right? We were given the red information for number 30. The first thing you're going to have to figure out is what case is it? What case was this one? Remember, you go around the triangle one way or the other without skipping over the big gap. So this would either be angle side or side angle angle, which is this one, right? The first 2 cases, angle side angle or angle side, are you going to have a pair? Yes. These 2, you can use the law of sine. And you just start solving. Those should be the easy ones. These 2 cases, we will be able to solve by the end of the week. But we need a different law, okay? Because you're not going to have a pair. I want to talk today about the bad one, okay? One that spells the bad word. And yeah, if you look up in a book, it's going to say side angle for obvious reasons, but I want you to remember that the one that spells the bad word is the one that causes the problem, okay? Basically, what we're dealing with here is this scenario. You're going to be given an angle, so let's say 48 degrees. You're going to be given a side, and then you're going to be given another side, okay? This case, there's a major problem here. This case may be totally impossible to build. It might be physically impossible to build a triangle with these 3 measurements in this location. It might be possible to build a triangle like this. It actually might be possible to build 2 triangles that are totally different triangles, but have the same 3 measurements in those 3 locations. The easiest way I can have you picture the problem is I want you to think of an excavator, okay? And basically what I want you to think of is, I want you to think of the ground right here, okay? I want you to think this angle right there is locked in place. You can't move that angle, okay? So the excavator is kind of broken a little bit, and this angle right here, the 48 degrees, we can't change that angle. Can we change the length of this side? No, you're not going to be able to stretch the steel. The length of that side does not change. So this measurement up here doesn't change. So this was like 12. And also, we have this measurement here. That length cannot change, but everything else can change, right? Now, I drew this ground as kind of an infinite line. There's nothing that says how big this line down here has to be. It could be really short or it could be really, really long. But basically what we're going to be able to do is take this arm and swing it. Now, as we swing this arm might come down and intersect the ground here. And then if you think as it starts to rotate, so it kind of hits the ground, creates one triangle, goes underground a little bit, and then as it's starting to come back out of the ground, that would be the same distance as this. Does that make sense? So now I have one triangle out here and one triangle in here. Those two triangles would have the same three measurements, but would be completely different triangles. That's one possible scenario. Another possible scenario is the drawing might look more like this. And if I swing this arm, what's going to happen? Will it ever intersect the ground? Sometimes this arm might be just too short and it's not actually going to reach the ground at all. So we have to figure out what is the scenario, okay? Now this stuff you're going to want to write some notes on. You want to take out and write some notes on it. Basically, we have three scenarios. We have scenario number one, okay? All right, I got to put a little asterisk here. Put a little asterisk in your notes above this. So in your notes, I'm going to keep writing angle A. All that means is the given angle. I don't want to have to write the given angle over and over and over again because it's going to get really weird. So I'm just going to say angle A, which also means side A refers to what? You can see where some of these notes would get really, really wordy if I started writing the given angle, if the given angle is this, and the side opposite of the given angle is this. I'm just going to start using capital A, angle A for the given angle, little a for the side opposite of the given angle. Does that make sense? And I'm just going to use little b as the adjacent side, basically the other side. So I'm going to, in the notes, just use those three letters, capital A, and little b. But basically what I'm talking about here is I'm just going to say the given angle right now for us, for the notes, is always A. In your homework, are they always going to give you angle A? No. But you trust me when I say you don't want me to write the notes over the next few minutes as the given angle and the side opposite of the given angle and the adjacent side. So I'm just going to assume it's always like this, okay? So, there's three scenarios. Scenario 1. If the given angle, so if angle A, if the given angle is obtuse. Okay, now, in this scenario, so they give us an obtuse angle. Let's say this is 120 degrees. Okay? And then they're going to give us two sides. They're going to give us angle, side, and then another side. Does this make sense? Why not? Huh?
It's the hypotenuse.
It's the biggest, it's got to be the biggest side, right? Does this make sense? Yes. Basically, here's what we got going on. Now I'm going to get fancy on you. Ready? Oh, I don't want that. I want this to go away. I want this one. All right. I got this fancy thing that I made. All right. Oh, no. You stay there. I did. I get fancy sometimes. All right. So here's my scenario. I've got a 120 degree angle. I've got a 10, and then let's say I got an 8 here. Is this triangle going to be able to be built? No, because this side's too small, it's not going to work, right? If this was a 18, basically meaning this side is longer, right? Can I make this triangle? And how many triangles can I make with these three measurements without changing this length, changing that length, or changing that angle? I can make a triangle, can I? Can I make a second triangle? As I go around, is that going to be able to build a second triangle? No. So, if this is the case, if angle A is an acute or obtuse angle, then the test is, well, then check if the biggest side is opposite the biggest angle. If the answer is yes, there is one solution. Start solving it. If the answer is no, there is no solution. Really is that simple. Like, it's not a difficult scenario. If you are given this scenario, angle sides, oh man, it's angle side side. Ooh, they gave me an obtuse angle. Is the biggest side opposite the biggest angle? Yes. There's a solution to this problem. I can start solving it. And I can start using the law of sine. Sine of 120 is to 15 as the sine of, where's my next part I'm going to have to find? B is to 10. Now, how do I solve that? What do I type into my calculator to solve that proportion? Well, I'm going to do 10 times, I got to do 10 times the sine of 120, get that answer. Then what? I do this times this, divided by 15, and then I get to here. And basically, what does that 0.5773 equal? It equals the sine of b. I don't want the sine of b, I want b. How do you get rid of the sine? You take the inverse sine. Now, this step right here, the inverse sine, is actually what's causing this whole scenario. Every single time you run into an angle side side case, you're going to have to take an inverse. Why does that create this scenario? How many answers are there anytime you take an inverse? There's two. The inverse part is actually what creates this whole dilemma of which angle is the correct answer. Now, for this scenario, because we've already established that there's only one solution to this, we don't care about the other solutions. This is the answer to angle B. I can just use this to start solving the rest of that triangle. I know that the only possible answer to this is 35.2.3. I can use 180 minus to find this, to create another law of sines, and I can solve that. Okay? Easy enough? So scenario one, easy, right? Obtuse angle. Scenario two. If the given angle is acute and A is bigger than B. I want you to think about what I just said. What is this scenario? They're given an acute angle. So 60 degrees. What else did I say? Actually, I want greater than or equal to, sorry. What's this next scenario? Let's say I put, here's B, here's 10. What's this side got to be? Give me a number. 12. So the scenario is this. The acute angle, the side opposite of the given angle, is the bigger side so far, right? Do I know this is going to be the biggest side altogether? I have no idea. All I know is it's the biggest so far. So let's go back to this little sketch here. So let's create an acute angle. So we have an acute angle. Basically, I need this scenario about right here. All right. Whoops. So I have an acute angle. This side's 10, this side's 12, right? How many triangles will I be able to create? As I start swinging my backhoe, it does finish one triangle here, right? Will I be able to create a second triangle? No. This is actually the easiest one. There's no test. If this is the case, then start solving it. It's just that simple. If you're given an acute angle and the side opposite is the biggest angle or biggest side so far, it's one solution. Here's actually another way to remember this. Regardless of the angle, if the side opposite of the given angle is the biggest side so far, how many solutions are there? One. Whether it's obtuse or acute, if the side opposite of the given angle is the biggest side so far, automatically one solution. Start solving. There's only a problem in this scenario. This is worst case scenario. And what would scenario 3 be? If angle A is acute and what? A is less than B. So basically, here's the case. We're given an acute angle. We got a 12 and a 10. This is the worst case scenario. And here's basically the way I want you to think of these. Oh man, it's angle side side. That's the one that spells the bad word. Oh man, they gave me an acute angle. Oh, the side opposite of the given angle is the smallest side so far. This is worst case scenario. This is the scenario where I have this scenario. I have an acute angle, my 12 and 10, right? This is where, when I swing this down, oh, it might be too short. It may not reach at all. It might be completely impossible to build this triangle. There's no way I can build this triangle. It's not going to make a triangle, right? Or maybe it's a little bit bigger. It's still smaller than 12, right? And oh, there's a triangle. And there's a second triangle. There might be 2 triangles here. Is it possible that there's one? How would it be possible if it's one triangle? What would have to happen to this side? It'd have to be just the perfect to where as you swing that down, it just kind of scrapes the grass, right? That arm of the excavator just kind of comes down and just barely touches. And if that's the case, as it's just barely touching, what kind of triangle do you think that is?
Right triangle.
That'd be a right triangle. If it's a right triangle, the whole SOHCAHTOA comes back into play, Pythagorean theorem comes back into play, and that's an easy scenario. What's that?
It's a right triangle.
You can still use law of sines too, but yeah. Okay? Now, if this is the case, if you have an acute angle and the side opposite of the given angle is the smallest side so far, then you must do the test. And you say, what's the test? Well, the test is this. I don't know if this side is, I don't know if this triangle is buildable, right? I have no idea. What I need to know is that distance. I need to find the height. Now, if this height comes out to be 11, what do I know about this triangle? It's not going to work. I can't build a right triangle like this, can I? If this side is too small, it's not going to work. If this height comes out to be 9, what do I know about this scenario? There's 2 solutions. It's basically either 0 or 2. There is the chance that it's 1. The only way that it's 1 is what happens to this height. It comes out to exactly 10. If it comes out to exactly 10, I know when I swing that down, it's going to create 1 triangle. So how do we find that height? Think about the given information. I have to find the height. How can I find this height? Well, think about this right triangle right here. What proportion can I write? What trig function can I write? That'd be opposite. This would be hypotenuse, so I can do sine of 70 is equal to h over 12, and I'll finish this tomorrow.